Section 5.3 is radical equation. So it's taking what we learned in the last two sections with adding and subtracting and multiplying and dividing, and then solving equations. So there's a little bit of the same stuff that we're going to do, plus a couple of different things, or a couple of extra steps, not really different, just extra steps being added on to what we need to do here. So it says, when we think of square root of 9, two solutions may come to mind, a positive 3 or a negative 3. However, when a radical is given in an expression or equation, only consider the positive response. So if we're solving x squared is equal to 25, when it says solve, then what we're going to do is we're going to find both that positive and negative answer. So this would be positive or negative 5 when we're solving it. When we're simplifying, we need to take a look at just what the question is asking. So if it's square root of 25, then we just need to find the positive square root because there wasn't a negative in front of here. So this answer would just be 5. Okay, so there's a little bit of a difference between solving and simplifying. Simplifying means take a look at what's there and simplify as much as you can. Solving means give me all the possible options. So it says in this section the radical is given in the equation, so only consider the positive solution. So steps to solving radical equations. Number 1 says you need to find the restrictions on the variable in the radicand if the index is even. So we did that, I think, in section 5.1 where we were looking at restrictions. Remember, the radicand must be set to greater than or equal to 0, and then we solve it. If you multiply or divide, then remember to flip that inequality sign. So that's nothing new. We did that in the first section there on solving radicals. Remember, if it's an odd index, like a cube root or a fifth root, you can actually have a negative underneath the radical sign because you could find a possible solution for that. So then the steps are the same after that. You get the radical by itself, and then if the index is a 2, you square both sides. If the index is 3, you cube, and so on, and then you solve for the variable. See if the solution is affected by the restriction. So once you have solved it, then you check back to the restriction. And then you need to check the answer in the original equation to see if the solutions are valid or extraneous. So even though they'll fit in with the restriction, doesn't mean that it isn't an extraneous root. So example number 1 says, 2 times square root 6x minus 1 is equal to 11. So if we take a look at that, what we need to do, first of all, is find our restriction. So we take whatever is under the radicand, whatever is under the radical sign, put it greater than or equal to 0, and solve for the variable. So in this case, we just divide by 6. So our restriction is that our values we use must be greater than or equal to 0. Step number 2 said to get the radical all by itself on one side of the equation. So if square root 6x is our radical, then we need to move everything else over. So I add my 1, I'm left with 2, square root 6x equals 12, divide by 2, so square root 6x is equal to 6. Step 3 then said if the index is a 2, then we need to square both sides. So our index is a 2, so if we square this and square this, we have 6x, because square root and square root cancel, is equal to 36. And then we just continue to solve for x. So x is equal to, whoops, not 36. X is equal to 6. So if I check back into my restriction, x had to be greater than or equal to 0, and it is. So now I need to check and see if, so number 4 worked out. So now I have to check my answer and see if I have an extraneous root or not. So to do that, I have to go back to my original equation, and I do a left side, right side check. So 2 square root 6x minus 1 is my left side of the equation. My right side is equals 11. So then I just substitute and solve. So 2, so this is my check. Square root is 6 times 6 minus 1. So 6 times 6 is 36. Don't need an equal sign there because the equal sign is in between. So 6 times 6 is 36. Square root of that is 6. So I have 12 minus 1, which is equal to 11. So my left side equals my right side. So my solution for this then is x is equal to 6. And it really helps when you're doing this, put a box around your restrictions and put a box around your final solution so that I can easily pick out which is the right answer. Okay, for B, I've got negative 8 plus square root of 3y divided by 5 is equal to 2. So first step is always take what's under the radical sign and find the restriction. So under the radical sign I have 3y divided by 5 greater than or equal to 0. So if I multiply by 5 to get rid of my denominator, I have 3y is equal to 0, greater than or equal to 0. Divide by 3, y is greater than or equal to 0. So that's my restriction. So now I need to solve and see what my final answer will be. So if I have a negative 8 here, that means to move it, I add 8. So I have square root 3y over 5 is equal to 10. Index is 2, so I square both sides. And you might notice that I'm putting that 10 in a bracket because I have to square the whole value that's there. And it's always just a good habit to get into because if that had been a negative 10, you need to make sure you square root negative 10 and not just the 10. So square root and square root cancel. I have 3y over 5 is equal to 100. Times each side by 5 to get rid of the divide by. So 3y is equal to 500. Divide by 3. 500 over 3. Unless the question says to solve to 2 decimal places or the nearest thousandth or whatever it is, leave your answers like that. Simplify as far as you can, but don't turn it into a decimal unless the question specifically tells you to find it to however many decimal places. So I'm saying my solution is y is equal to 500 divided by 3. I check in my restriction, and that is greater than 0. So now I have to check to see if it is an extraneous root or not. So I do my left side, right side. So on the left side of the equation, I had negative 8. Oops, sorry, write that above here. I didn't really need the line across, but it doesn't matter. Square root 3y over 5, and the right side is 2. So negative 8 plus 3 times 500 divided by 3 divided by 5 is equal to 2. So 3 times 500 divided by 3, those will cancel. So I'm left with 500 divided by 5, which is 100. So I've got negative 8 plus square root of 100. So negative 8 plus 10, which equals negative 2. Positive 2. My right side equal positive 2, so my answer is right. So this is my solution. Okay, next example. Solve for 4 plus square root 2x minus 3 is equal to 1. So my first step is going to be to find my restriction. I'm just going to do that above here. So 2x minus 3 is the radicand. So that's greater than or equal to 0. 2x is greater than or equal to 3. Divide by 2, so x is greater than or equal to 3/2 is my restriction. So now I'm going to solve. So my first step, I have to get that radical by itself, so I move my 4. So I have square root of 2x minus 3 is equal to negative 3. So if I square 2x minus 3 is equal to 9. 2x is equal to add 3, 12, x, oops, I'll divide by 2. So x is equal to, just move that x down, x equals 6. So if I check in my restriction, 6 is greater than 3 halves, so that'll work. So now I do my left side, right side check. So I have 4 plus square root 2x minus 3, and on this side I have a 1. So 4 plus square root of 2 times 6 minus 3. 4 plus square root of 12 minus 3 is 9. So 4 plus 3, well, that equals 7. And if you go back and check your math, I haven't made any mistakes. I didn't make any mistakes there. This is an extraneous root. So how can this be an extraneous root when it fit in with the restriction? So this is not equal to 1. So we say that this is an extraneous root. And the reason I know that this is an extraneous root is right from kind of my first step of solving, right here. What I had there before I squared both sides, I had the square root of 2x minus 3 is equal to negative 3. There is never a time that a positive square root can equal a negative number. So right away, as soon as I see a question like this, and this is just a hint for you for future solving, as soon as I can see that I have a square root or a fourth root, so any even root equaling a negative number before I even finish solving, I know I have an extraneous root. So your kind of hint here is you can never square root a value and get a negative answer. So that means that this is an extraneous root. I cross it out and I say there is no solution. Okay, and I put, we can never square root, but remember that's any even root. Okay? So sometimes you might not recognize that right away and you work your way through the whole thing, but if you do, then as soon as you recognize it, then your work is done and you can just give me that reason, and you're finished. Okay, the next one. M minus 2m plus 3 is equal to 6. So first I do my restriction, can't say that word. 2m plus 3 greater than equal to 0. So 2m is greater than equal to negative 3. M is greater than equal to negative 3 halves. So now let's solve. So if I move my m over, I'm left with negative square root 2m plus 3 is equal to 6 minus m. I have this negative value in there, so I need to get rid of it. So there's two things that you can do. You can either divide by a negative or you can multiply by a negative. So I'm just going to do I'll multiply both of these sides by a negative 1. I'm not changing anything on this left side. I'm just going to get rid of that negative. So that becomes square root 2m plus 3 is equal to, this will be negative 6 plus m. So I'm just going to change that to m minus 6. So now I need to square both sides. So squared and squared and square root cancel. I have 2m plus 3. I'm I'm squaring a binomial. So remember, when you square a binomial, you have to end up with a trinomial. You have to end up with two terms. The short trick way of squaring this is you square the first term, so that's an m squared. Then I take each one of these terms, the m, the negative 6, and the 2, or each value, and I multiply them together. So m times negative 6 is negative 6 times 2 is negative 12m. That gives me my middle term. And then I have to square my last term, so negative 6 squared is positive 36. So what I did there, and I'll just write it over here, I think I've showed you this before. I square my first term, and then my next term is going to be m, I should put a plus sign in between there, m times negative 6 times 2. So I take every value and multiply it together to get my middle term, and then my last term is always the last term squared. So this becomes m squared minus 12m plus 36. So now I need to solve. So to solve for m, I have to bring everything over to one side and find my answer. So if I subtract 2m and I subtract 3, so I'm left with 0 is equal to m squared minus 14m plus 33. So this is where last chapter's information comes in, because now I've got a trinomial and I need to solve for the equation. So I can do my complete the square method, I can use a quadratic formula, or I can just factor using product and sum or slide and divide, whatever would work. This one is an easy enough one that you could use a quadratic formula or the complete the square, but that's going to take you way more work. If you just recognize this as a product and sum, I need something times something to equal 33, and to add to give me negative 14. So negative 11 and negative 3 will multiply to give me positive 33, and add to give me negative 14. So 0 is equal to m minus 11 times m minus 3. So I take each factor, put them equal to 0 and solve, so m is equal to 11, m is equal to 3. Second, my restriction. 11 is greater than negative 3 halves, 3 is greater than negative 3 halves, so it works for the restriction. Now I need to try it for that extraneous root. So if I do my check, I'll do the 11 first, so 11 minus square root of 2 times 11 plus 3 equals 6. So this is 11 minus 22 plus 3 is 25. So that's 11 minus 5, that equals 6. So that one works. So now I need to check it for 3. 3 minus 2 times 3 plus 3 square rooted equals 6. 3 minus 6 plus 3 is 9. So 3 minus 3 is 0. Doesn't work. So this is an extraneous root. So I cross it out, put my box around, m is equal to 11. Okay, next one. This one has 2 values underneath the radical sign. So it's got 2 radicands. So that means I have 2 restrictions that I have to take a look at. So the first one is that square root 3x. So 3x greater than or equal to 0, so that's just x is greater than or equal to 3. So that's my first restriction. Second restriction, 5x plus 4 greater than or equal to 0. So 5x greater than or equal to negative 4, divide by 5, x is greater than or equal to negative 4/5. So that is my second restriction. So now I need to solve. So when you're working with a question like this, where you have 2 radicals in the equation, what you need to do is just make sure one of them is completely by itself, and then do your squaring. So it doesn't really matter which way you go. Because this has a binomial in it, I'm going to, just because it makes it a little bit simpler to do the solving, I'm going to get that one by itself. So if I want to get this by itself, I need to move my 5. So 7 minus 5 is 2. 2 plus square root 3x is equal to square root 5x plus 4. Okay, so now I need to do my next step, which is I have the radical by itself, so I have to get rid of that. It's an index of 2, so I square both sides. So on this side, I have a binomial being squared, so I need to do my shortcut answer. So first thing I do is I square my first term, so that becomes 4, plus my middle term is equal to 2 times square root 3x times my exponent of 2, so that's 4 square root 3x. And then my last term in my binomial is I have to square that last term. So square root 3x all squared. Squared and square root cancel, so it's just 3x. So on this side, I have 5x plus 4. So I'm going to do the same thing. I'm going to do that step one more time. I need to get this radical by itself in order to finish solving. So I have to move over my 4. And I need to move over my 3x. So by doing that, I'm left with 4 square root 3x is equal to 3x, those canceled, sorry, 5x minus 3x is 2x, 4 minus 4 is just 0. So I'm left with 4 square root 3x is equal to 2. Divide by 4. So I have square root 3x is equal to 2x over 4. Or I could reduce that to a 1/2. And actually, that's what I'm going to do. So 2x over 4 is the same as x over 2. So now I've got my radical by itself. I square both sides. Remember, if you square a fraction, you square the numerator and the denominator. 3x is equal to x squared over 4. Now I need to finish solving. So if I multiply by 4, I have 12x is equal to x squared. Now what we don't want to do now is go, okay, I need to get rid of the squared, square root both sides, because then I'm just back to right where I was before. So what I need to do is bring everything over to one side and solve. So x squared, that if it was a positive 12x, it's going to be minus 12x. So now it's just a factor. I can GCF an x, and I'm left with x minus 12. So x is equal to 0, or x minus 12 equals 0. So x is equal to 0 or 12. So if I take a look at that in my restrictions, 0 and 12 are both greater than or equal to negative 4/5, so it works there. So that means I have to try it into my extraneous roots. So my check. 7 plus square root of 3 times 0. My left side, whoops, I don't need to make that quite so big. And my right side was 5, whoops, square root 5 times 0 plus 4 plus 5. So this is 7. 3 times 0 is 0, so it's just 7. And this side, 5 times 0 is 0 plus 4 is square root of 2. Sorry, square root of 4 plus 5, so that's 2 plus 5, so that is 7. So this one works. So then I need to check for my other solution of 12. So I have 7 plus square root of 3 times 12 equals, whoops, I don't need the equal sign, I just need my bar. Square root 5 times 12 plus 4 plus 5. So on this side I have 7 plus square root of 36. So that's 6. 7 plus 6 is 13. On the other side, I have 5 times 12 is 60 plus 64 plus 5. So that's 8 plus 5 is 13. Left side equals right side. So my solution is 0 and 12. Okay, and the word problem on the next page, I'm going to leave that one for right now. I'll do it in class with you just so you can have some or see how a solution like this is done. It's better for me to do it when you're actually watching because it takes a little bit of, you need to have some actual, not diagrams, but shapes to show you what I'm talking about, because otherwise it gets a little bit confusing for this particular problem. So otherwise, your assignment here at the bottom, the page 300 is the questions for 5.3, and the 304 are the chapter review questions.